I had a couple questions from Chapter 5 on the problems that we're dealing with the steers. And they wanted you to, in this problem, define percentiles. And so when we're talking about the 57th percentile, that would be the z-score that corresponds to an area of 0.57 to the left. So if I open up the normal table, and this is on page A66, 67 in your book, I want the area to the left here to be 0.57. So I know it has to be a positive z-score, because up to 0 would be 0.5. So I look in the body of the table, and I find the number closest to 0.5700, which would be right here, 0.18. So if I'm going to do this by hand, I want to find the steer weight that's 0.18 standard deviations above the mean. And that's what I've done right down here. The mean is 1,112, and I'm going to add 0.18 numbers of standard deviations, the value of which is 75, so I get a weight of 1,125.5 pounds is the steer weight that corresponds to the 57th percentile. Now, I can also do this in StatCrunch, so I can go to Stat, Calculator, Normal, and I'm going to set this up with the steer weight, which remember was 1,112, and the standard deviation was, let me make sure I get the right value, 75. All right. And now I want the 57th percentile, so I'm going to go ahead and I'm going to put in an area of 0.57 in this space here, and I'm going to find out what the weight is, and it's 1,125.2.3. So approximately what I got when I did it by hand, a little bit different because of rounding. Now I also had questions on these here, which is the same scenario, a little different weight and standard deviation, but they want to know the highest 10% of the weights. So again, I want to find in the body of the table, so I want to find if I have the highest 10%, that means, let me get the little picture up here, 10% up here, but that means the area to the right must be 0.90. So I look in the body of the table and I find the number closest to 0.90, which looks like it's right here, which is 1.28. And so if I take that, this had a different mean weight, so it was 1151. So if I find the steer weight that corresponds to 1.28 standard deviations above the mean, I come up with a steer weight of, I didn't put the right answer down there, and I apologize for that. It should be 1151, it should be 1262 point, rounded up 0.4. Oh, 1262, sorry, 1262.4. Again, I can do this in StatCrunch. So if I go back to my StatCrunch tool, and if you remember on this one, the mean weight was a little bit different. It was 1151, and the standard deviation was 87, I believe. Yeah, and we want the highest 10%. So I'm going to put in here, I'm going to change this to greater than, and I want the area here to the right to be 0.1. And so I get 1262.5, and by hand I got 1262.4. So either of those answers would be acceptable. So I would urge you, if you can get comfortable with these normal calculators, it's a whole lot easier to work these. And remember, there's also an option here to go between two weights, and you can also set up the tick marks like we did with the empirical rule here, where it does -1 standard deviation, -2, +1, +2, etc. So hopefully this will help you as you're working on your homework for Chapter 5.